Hello there. In this video, we're going to talk about solving for the x-intercept of a linear equation. Now, in more general terms, this can also be sometimes called the root. If we think about a graph, we're not graphing in this video, but if we just think about a graph, and specifically the graph of a linear equation, okay, there's my general linear equation. That x-intercept, I always like to think, where does the term root come from? I like to think of a tree. The x-axis is the ground, okay? All trees sprout up from the ground, okay? Anything down here is below ground, and everything up here is the tree itself. But then what is this called? This is called the root of the tree. Now, a tree has more of a root system, but this is where the graph roots itself. Okay? But for the terms of this video, I'm probably going to be describing it more as an x-intercept than as a root. Roots more come into play when you get into polynomials because there's multiple of them. So we have to think about what it means to solve for an x-intercept, because in the end of the day, it's just solving a simple equation. Okay? Remember that x-intercepts have a y value of 0. We don't know what the x value is, but we know the y value is 0. If we're plotting something on the x-axis, we haven't moved up or down. So when I come to my equation, I can start by plugging in 0 into y. Okay, and now I have to solve. I have to isolate the x value. So using reverse PEMDAS, reverse order of operations, I'll start with, let's recall, reverse order of operations. I'm writing it in the opposite order because we're starting up here. I'm dealing with addition and subtraction first. Well, here's an addition. To undo that, I have to subtract it. But what I do to one side, I must do to both. Okay, great. Go ahead and cross that off, and I get -3 equals to -2x. Now, I don't have any more addition or subtraction at this point, so it's on the multiplication division. I have a multiplication right here. I have a -2 times x. Well, to do that, I just got to divide by -2, but again, do it to both sides. And I know that these negatives will cancel out, and I end up with 3/2 is equal to x. You could write x is equal to 3/2. Or let's write it as x equals 1.5 so we get a better understanding of what that value is and where it lies on the number line. It lies halfway between 1 and 2. And so the x-intercept of this graph would be at 1.5. Okay, great. Let's try another example in slope-intercept form. Again, I'm going to start by plugging in 0 for y. And I'm going to get 2/5 x minus 3. And again, I'm dealing with addition and subtraction first. So I have a subtraction right here. I'm going to go ahead and add 3 to both sides to undo that. These will cancel, and I'm left with 3 is equal to 2/5 x. Now, this can get a little bit tricky sometimes when you're not comfortable with fractions. You know, what do we do with next? We deal with multiplication and division. Well, fraction has multiplication here and division in the fraction sign. So what do we do? Well, you can do one at a time. You can multiply by 5 and then divide by 2. Or when we're dealing with fractions, we can think of it as just a simple division. But let's note off to the side, 2/5 divided by 2/5. That's a complex fraction. How do I undo that? Well, this is the same as saying 2/5 divided by 2/5, and we can apply our keep, change, flip, and then we can cross simplify. The 5s would cross simplify, and the 2s would cross simplify, and we're just left with 1. So let's do that here. So I've already done the math. I'll just write it out here. Multiply by 5/2. When you see a fraction coefficient, go ahead and multiply by its reciprocal. So again, these will cancel and these will cancel. Now when we get to here, we got to remember this is 3/1, and we use fraction multiplication to simplify this. So 5 times 3 is 15. 2 times 1 is 2, and we have our final answer. And 15 has, if we want to know where this would line on the number line, this would be 7.5. Okay, so for the last one, this will look familiar because it was shown in the last video. We know what to do. We're doing the same thing. We're plugging in 0 for y. And we have to just think in as simple terms as possible. When we're multiplying by 0, we're going to get 0. And in this case, we could be adding or subtracting by 0, or we could be adding or subtracting from 0. Either way, you get a positive or negative of what's left over. In this case, we're subtracting 0, so we can just go ahead and cancel out because we're just going to be left with 3x. This is the benefit of multiplying and plugging in 0. And then we're just a simple division away from solving this problem. We get x equals 8. Now, why do I show you these problems again? Well, I want to show you the algebraic process of how to work out the x-intercept. But I kind of want to go in the general form. I've always noticed that there are two kinds of people in math. There's the ones who love the procedure. They love to work it out. They love this. They love the algebra. And then there are some people who would prefer the shortcut. They want the formula. They want as simple a way to the solution as possible. And there's nothing wrong with that. So what I'm going to do for you in this video is solve for the general form. That means no numbers, and then using those to plug in the numbers. So we have the y equals mx plus b, but our goal hasn't changed. Solve for the x-intercept. So I'm going to plug in 0 for y, and we're mx plus b. Now, in both examples, we were adding or subtracting the y-intercept. Since the general form is plus b, I'm going to subtract b. Okay, and we get 0 minus b is negative b, and that equals to mx, and then we undo the multiplication by dividing. And we get, I'm going to switch it around, x equals negative b over m. Okay, let's go ahead and prep that on the next slide. I was going to go over it. So x equals negative b over m. I'll write that for all the irrelevant problems. Negative b over m. Okay, great. That's the general form of an x-intercept. That's the formula. You don't have to work out the algebraic processes. If you memorize this formula, go for it. Same idea in this next one. We're plugging in 0 for y. And we've seen this trick 100 times. Oop, I didn't plug in 0. That's my bad. All right. You're multiplying by 0, and then you're adding 0, which means nothing changes for the ax. We just have ax equals c. And we've seen this a bunch of times. We just divide by a, and we get the general form c over a. All right, let's go ahead and write that here. X equals c over a. So without using algebra, just by using the formulas that we've derived, let's go ahead and try these out. Okay, so you have to know what's m and what's b, obviously. So we have negative 2, that's m, and then the positive 3, that's b. So when I'm writing out this solution, I'm writing x equals a negative, because the negative is attached to the formula. We always start with a negative. And then a positive 3, okay? And then we're going to divide by our m value. Sorry, I might have said negative b. So negative b, correcting it for the record just in case I misspoke, divided by m, which is a negative 2. And then all we have to do is simplify. That's plus, since a negative divided by a negative is a positive, and we get 3 halves. Let's go back and reflect. That's what we got on this answer. So our formula worked. But we know it works because we generalize the formula for all problems. Let's go ahead. Again, here is our m, the 2/5, and our b is a negative 3. Okay, so we've got x equals a negative. The formula comes with a negative, so we always have to write that in there initially. And then a negative 3 all over 2/5. Okay. Now, a little bit more simplifying to do. We have a negative of a negative. That's just a positive 3. But then we also have to simplify this complex fraction, which means we need to multiply the top and the bottom by 5. So this can cancel. And we effectively get 3 times 5, which is 15. And we're left with the 2 in the denominator. And look at that. We got our solution right there. Okay, let's do the one last solution. This time we need to know what A, B, and C are. B is not going to be used in this formula, but it's still helpful to point it out to know that we got A and C correct. And so as long as you have X, Y, and a constant written in that order, it's just a simple A, B, and C. And so our formula is C divided by A. So that would be X equals 24 divided by our A, which is 3. And then we simplify. This is just division. 24 divided by 3 is 8. And if we go back and look, that is what we got here. So moving forward, go ahead and choose which option you prefer. I always prefer the algebra because it requires less memorization and relies more on habit. Okay? If you liked this video, go ahead and give it a like and subscribe to the channel. And if you want to see future videos, go ahead and leave those in the comment section, pardon me, and I will see you for the next video. Thanks for watching. All right. I think I can call up there. Because I think